Hi, so today we're going to be talking about logic statements in geometry. So these logic statements are just different ways to say something but mean the same thing. So let's start off with our statement, if P then Q. And throughout this lesson I'm going to be using P and Q over and over again. I hope it works for you. So converse. Converse is saying just switch P and Q. So if Q, then P. Now, a way you can say that is if it is sunny outside, it's not going to rain. Then it's not going to rain. So then if it's not going to rain, then it's sunny outside. Now that's not necessarily true, but we'll use that as an example. The inverse, it's saying if not one way, then not the other way. Inverse, you just use the same statements, so the same order of the statements, so if P then Q, except you put a not in front of it. So if not P, then not Q. And then next we got to work on the contrapositive. Now we've switched it, and then we've made it negative. Now what's next? Well, we're going to make it negative and switch it. So if not Q, then not P. And so those are our three basic logic statements. There's another thing I want to talk to you about. So next we're going to be talking about the law of syllogism. Let me go check that. So the law of syllogism takes two conditional statements, if P then Q, if Q then R, and just takes out the middle. It takes out this. So it's going to be if P then R. A way that I was told that always made me remember it, I don't know why, maybe it's just the way, maybe just because it's a little funny thing, but when I was learning this, my teacher told me, if you pick your nose, you're going to break the skin. If you break the skin, your nose is going to bleed. Therefore, if you pick your nose is going to bleed. I never forgot that. Maybe it will work for you too. So that is the law of syllogism. Now we also, earlier I mentioned how if it's not going to rain, then it's sunny. But we all know it could not rain and still not be sunny. Heck, if it snows, it's not necessarily, that's not really rain, and it's probably not sunny. So these don't necessarily have to be true. But if the statement does say that they are biconditional, if it says biconditional, then they are. So that means if Q, then P. So if it says biconditional, then it does have to be the opposite. So if you're working, and this is especially useful in math. An example of a biconditional statement would be something like, if, I'm not even going to write this, listening ears. If an angle is less than 90 degrees, then it is an acute angle. If it is an acute angle, then it is less than 90 degrees. It is true for both ways you say the statement. Something that isn't true. If it is Labor Day, then you don't go to school. If you don't go to school, then it is Labor Day. This is an example of a non-biconditional statement. Because you're not at school on weekends, not every weekend is Labor Day. So those are our main things about logic statements in geometry. Hopefully it helped.